So on chapter 12 D-Day, on number 1, Ron and Michelle and Tina all want to be on the prom decorating committee. The class advisor must choose 4 out of 10 people. Okay, so we got 4 out of 10 people that sign up to be on the committee. How many different 4-person committees are possible? So committee order is not important, so it's going to be 10 choose 4. And just a reminder, that is 10 factorial over 4 factorial times 6 factorial. And if I put this in my calculator, 10 choose 4 is 210 different ways. What is the probability that Ron, so probability, okay, that Ron, Michelle, and Tina are all on the committee? So for this one, the denominator is going to be the 10 choose 4 that we just worked out, because that's all the ways to get committees of 4. When we're trying to get Ron, Michelle, and Tina all together, that means that we're basically going to have one other person that's going to be picked. So since 3 people are already going to be in the committee and there's 10 people total, that means 7 people are left for 1 position. So this is going to be 7 choose 1. And 7 choose 1 is 7. So it's going to be 7 out of 210, which is 1 out of 30. And that's your answer. On number 2, out of 36 RBV students selected, 20 are 16. Okay, so 20 are 16-year-olds. Okay, and we've got 36 RBV students total. 10 are 17-year-olds, 5 are 18-year-olds, and there is 1 15-year-old. If 4 people are chosen randomly to form a committee, find the probability that 3 students are 17 and 1 student is 16 years old. Okay, so it is a probability. And we are trying to get a 4-person committee. So my denominator is going to be 36 choose 4. That's going to be the denominator. We want to know the probability that 3 students are 17 and 1 student is 16. So 3 students are 17, there are 10 17, so that's going to be 10 choose 3. And so it's going to be multiplied, because this is 4 people total. So far I only have 3. My other person is going to be 1 16-year-old. And there are 20 16-year-olds, so it's going to be 20 choose 1. And then we're going to work this out. So let's see, 10 choose 3 times 20 choose 1 divided by 36 choose 4. And I ended up with, so the final answer as a decimal is going to be 0.0407 about, okay. If I am just figuring out the numerator, um, 10 choose 3 times 20 choose 1 is 2,400. The denominator 36 choose 4 is 58,905. So that would be the fraction, and this would be the decimal. Next question, out of those 4 people, what is the probability that each student is a different age? So again, it's still going to be out of that 36 choose 4, but now each one is a different age. So I'm going to have a 16-year-old, and there's 20, so that's going to be 20 choose 1, times a 17-year-old, there's 10, and I'm going to get 1, so 10 choose 1, times 5 18-year-olds, we're going to pick 1, so that's 5 choose 1. And then the 15-year-old, that's 1, there's 1, and we're going to choose 1. And then we're going to put this in our calculator. Now 20 choose 1 is 20, 10 choose 1 is 10, 5 choose 1 is 5, and 1 choose 1 is 1. We end up getting 1,000 over the same thing we had over there, 58,905. If I did this math and I did the division, I'm going to end up with 0.01, let's say 70 if I'm rounding, would be my answer. On number 3, Emily's little sister had 6 Barbie dolls, Skipper, Ken, Tootie, Todd, George, and Margaret. One day she decided to play with 3 of her Barbies. How many different choices did she have? So she has 6 Barbies, and she's going to choose 3, so it's going to be 6 choose 3. And 6 choose 3 is 20. Okay, because order's not important in that situation. Then it says she liked all of her Barbies, but one day she decided she had favorites, a first, a second, a third, and a fourth. In how many ways could she choose her top 4? So that would be a permutation. So that's going to be 6p4 and 6p4 is equal to 360. Okay, on number 4, we have how many different arrangements of the letters in the word trapezoid are there? So we're going to count the letters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 factorial. But then I need to look and see if I have any repeats here. So no T, R, A, P. Nope, no repeats there. So it's going to be 9 factorial. And 9 factorial is equal to 362,880. That's going to be our answer. Find the volume of a sphere with a radius of 6. So if our radius is 6, you can kind of think of a sphere by also thinking of like if it had been a cylinder, okay? And so if this had been like a cylinder, that would be kind of equivalent radius and height. My radius here is 6. The height, if I was thinking of this as a cylinder, is going to be the diameter, and the diameter of this is 12. So I'm really basically going to do 36 pi because it's pi r squared. Okay, that's this is pi r squared. And then I'm going to take that and times it by 12 to get volume of a cylinder, if I'm thinking of a cylinder. Now, 2/3 of a cylinder would be a sphere. And so when I do that math, I end up getting 288 pi centimeters cubed as my answer. On number 6, okay, we are going to be using this circle here. Z is the center. We're going to calculate the area of circle Z, sorry. So first thing I need to do is I need to figure out this diameter so I can figure out my radius, okay? So I know that this has to be a right angle because this is a diameter. So that is a inscribed right angle there. So I've got 6 on this side. Okay. I need to find, I'll put D for diameter. What I do know is since this arc here, the arc measure is 50, this inscribed angle is going to be half of that, which is 25. So to find my D, I am going to be doing adjacent over hypotenuse. So I'm going to do cosine of 25 degrees is equal to adjacent over hypotenuse. And then I'm going to work this out. So I'm going to get D cosine 25 degrees is equal to 6. So D equals 6 divided by cosine of 25 degrees. That would be the diameter. Okay. I have half of that for a radius. So hold on, let me do this. So my radius is going to be half of that. And so I can work this out. That's going to be 3. So it's going to basically be 3 cosine of 25 is my radius. Okay. So now I'm going to take that radius. I can put that in my calculator here in a second, but I'm going to take that radius and I'm going to use it to find the area. So area is pi r squared. So I'm going to get pi times 3 over cosine 25 squared. So I'm going to work that out. So 3 divided by cosine of 25 squared is going to be basically pi times about 10.96. And so let me just put that in my calculator and get a decimal. So that's going to equal 34.42 centimeters squared. And then we want to calculate the length of YV. So if I'm looking at the length of YV, I am looking at this, and that's an arc length that we're looking at. This should have been like this. Okay. And so I want the arc length. Now I know that together my pink and my, let me just do it like this. This green all the way to here to this pink forms 180 degrees. Okay. And so since that's 180 degrees, I know that the arc measure of that green section is going to be 130 degrees, but that's arc measure, not arc length. So to find arc length, I need to find the circumference. And I'm going to have 130 out of 360 times the circumference. And circumference is equal to 2 pi r. So, or pi times diameter, and here's my diameter, 6 over cosine 25. So it's going to be 6 over cosine 25 times pi. And so let me just do that math. Okay, 6 divided by cosine of 25. And let's see, I am going to end up getting this to be about a 2.39 pi. And let me times it by pi to get an actual decimal. So this is going to be 7.51 centimeters is the arc length. On number 7, this is a trapezoid, and the area of so we have to find area and perimeter. Area of a trapezoid is base 1 plus base 2, that quantity times your height divided by 2. So I don't know everything. I'm going to split this. And so I'm going to know that this is 20. And I need to figure out this length right here. And I have a right triangle with a 30 degrees, and I want to find this. I'm just going to call that X. So I am going to have sine of 32 is equal to opposite over hypotenuse. So 17 sine 32 is my X. So that's going to be the height. And I also am going to need this piece right here. I need this base, this piece to add to my base. So that is going to be cosine of 32 is equal to, I'll call it B. B over 17. So 17 cosine 32 equals B. So when I'm trying to find my area, okay, I am going to take my top base, which is 20, plus my bottom base, which is going to be 20 plus 17 cosine 32. I'm going to be timesing that by the height. Let me move this. Okay, so let's see. See if I can move this. Okay, and let me just rewrite my B. Okay. So for this, again, for my area, I am going to take this. Hold on one sec. So this right here is going to be my area. So I'm going to take my base 1 and base 2, and then I'm going to times it by the height, which is 17 sine of 32 divided by 2. And I will put that into my calculator. And I ended up getting for this 245.11, and that's going to be inches squared. That's going to be my area. Perimeter is going to be adding up all the way around. So for my perimeter, okay, I'll do that in orange here. I'm going to have 20 plus 20 plus 17 cosine 32 plus over here, that's the same as the height. So that is a 17 sine 32 plus the 17, this 17. And so when I put that all in my calculator, I got 80.43 as my answer. And in terms of units, this would be inches. Okay, on number 8, a tree extends from the top, a string extends from the top of a tree to a point 10 feet from the base of a tree. If the string is 30 feet long, how tall is the tree? Okay, so basically I'm going to have something like this. This is 10 feet away. The string is 30. We want to know how tall the tree is. And so we can actually, for this, use Pythagorean theorem. So I'm going to be doing basically 10 squared plus, let's call this b squared equals 30 squared. So I get b squared is equal to, let's see, 900 minus 100, which is 800. So b is equal to the square root of 800. And the square root of 800 isn't a nice number, but in 800 is a, let's see, we have a 400. So that is going to be a 20 root 2 when I simplify that, because the square root of 4, 102, that gives us 800. So that's a 2. That's a 10. That's your root 2. So how tall is a tree? That's how tall the tree is. Now, as a decimal, 20 times 2 to the square root of 2. Let's say 20 times square root of 2, sorry, is a 28.28 feet. On number 9, okay, and I'm just going to draw them here on this graph instead of on the other graph, okay? So this one here is going to be this, here I'm not going to do it in blue, use a different color since I have blue on there. So let's say I do this one in orange. Okay, so that minus 1 is going to drop every point down 1. So I'm going to have a point here, point here, point here, point here. And then we can connect the lines. For the other one, I'll do it in pink. This one here, f of x minus 1. So for this one, everything's going to be moved to the right one. So I'm going to have here and here and here and here. And that's your graph. Okay. On number 10, we're going to, on this one, let me just get the picture a little bigger here. Calculate angle X. So we want the arc measure. Let's get it here. So we want this arc measure right here. Okay, that's a little too fat. with this arc measure. And we want this angle up here. Okay, so we want this angle right here. That angle, that's what we want to find. So for this, what we can do is I know that first thing let me focus on is the following. Let me focus on this. If this angle right here is 31, then I know that this, and here, let me continue that. So that's going to go all the way to here. Okay, so if I know that that's 31, that is going to make this right here, that arc, be twice as much, which is going to be 62. Okay. Now, if that is 62 because of that inscribed angle, that means that since this is the center, this is going to also be 62 because that's the central angle. Now, if that is 62, I know that this together is going to make 180. And so 180 minus 62 is going to be 118. So this right here is going to be 118. And if that is 118 and that forms that central angle, this arc is going to be 118 degrees. Now, if that is 118 degrees, I know that, let me get rid of this for a second. I know that also, because this is tangent to this point right here, that this radius is going to meet this at 90 degrees. So I have a 62 degree angle in basically this triangle right here. 62 degrees, I have 90. And so to find this, I'm going to take 180, sorry, minus 90, which is 90, minus 62, which is going to be 28. And this is going to be 28 degrees. On 11, we have O is tangent at AC. So this is going to form 90 degrees here. And BC, so this is going to form 90 degrees here. And we know that measure of angle AXB, so AXB, and this, so AXB is 210 degrees. So looking at this, I believe this should have been that we want measure of arc AXB, okay, to be 210. So that is going to be right here. AXB going all the way to here is 210 degrees, which means over here on this side, this is going to be the rest of the 360. And so that is going to be, let me just draw it right here like this. So that is going to be 150 degrees. Now, if that is 150 degrees, when I draw this line Okay, and here, let me say this before I do this. That means that this is also going to be, let me color code it. This is also going to be 150 degrees. Okay, that other pink angle, that's going to be a central angle. And then if I am cutting this in half to come here, and this again is a right triangle, when I split 150 in half, this is going to be 75, and I have 90. I know that OA is 8. Okay, so this, hold on, this radius here, I'm going to do in orange. This is 8. Well, this is also a radius, so this also has to be 8. So now when I'm trying to find BC, okay, this is BC right here. I have an 8 and I have a 75 degrees, and I'm going to try to find, I'm just going to call this X. So I am going to be using opposite over adjacent. So I'm going to do tangent of 75 degrees equals opposite, which is X, over adjacent, which is 8. So 8 tangent of 75 degrees is going to equal X. And if I put that in my calculator, I end up with 29.86 degrees. I mean, not degrees, sorry, just 29.86. They didn't give us any units. And that's what BC is. That is our BC. Okay. On 12. Okay, so we want the volume of this. So if I'm doing Pythagorean theorem here, this is a right triangle. I have a 12, I have a 13, and this is a 5. You can do Pythagorean to figure it out, but it is a triple. 5, 12, 13 is a triple. So if I'm trying to find the area of that triangle here, this is 5, this is 12, this is 13. I needed to use the base and height, which are perpendicular. So I'm going to go 5 times 12 divided by 2. So that's 6 times 5, or 30. That is going to be the area of this. And then I'm going to times it by the height. And the height is 7. So for volume, I'm basically going to take 30 times 7, which is 210. And that is your volume. And this is going to be meters, sorry, cubed. On 12B, we have a square-based pyramid with a slant height of 5. So this right here is 5, okay? And we want to find the volume. So this is a square. So the square base is going to be 36 because it's 6 by 6. And then I need to find the height. So when I'm trying to find the height, I've got that slant height, which is 5. This is going to go halfway across that 6, which is a 3. So this is going to be a 3, 4, 5 right triangle. So then the volume, if this had been a prism, would be 36 times 4, but because it's a pyramid, I'm going to divide it by 3. And so I'm going to get 48 when I do that math, and 48 centimeters cubed. So if I'm going to graph this, and find these pieces, the first thing I probably would do, let's see, is maybe, well, here, the very first thing, this 12, that is going to be, or 0, 12 is going to be our y-intercept, okay? Because when it's in the form y equal ax squared plus bx plus c, c is going to be our y-intercept. Let me find my x-intercept. So I'm going to set this equal to 0. So this is going to be negative x squared plus 4x plus 12. I am going to multiply everything by a negative. So I'm going to get x squared minus 4x minus 12. I'm going to factor that. And I'm going to get an x minus 6 and an x plus 2. So my x-intercepts are going to be 6 and -2. So I have 6, 0 and -2, 0. Now for your vertex, since I have my x-intercepts, what I could do is I can average them. And so I can go 6 plus a -2 divided by 2. So that's going to be 4 divided by 2 or 2. So I know it's going to be 2 comma something. So to figure out the something, I'm going to put 2 into the equation. So let me do it up here. So I've got -2 squared plus 4 times 2 plus 12. So this is going to be -4 plus 8 plus 12. So that's going to be 4 plus 12 or 16. So this is going to be 2 comma 16. And then they wanted us to graph this. So I have a y-intercept at 12. Okay, y-intercept at 12. I had a vertex at 2 comma 16, 2 comma 16, 2 comma 16. And I had x-intercepts at 6 and -2. Let me first get my symmetry here. So I've got a point on either side. And then I have again at 6 and -2. So 6, whoops, 6 and -2. So -2 and 6. And here is our parabola.